To find the derivative of f of x equals 3 times the secant of x squared plus 3, the chain rule must be used. This is because we're taking the secant of x squared plus 3 and not just the secant of x. If this problem was 3 times the secant of x, this would not require the chain rule, but because it's the secant of something more than just an x, then the chain rule is required. Let's recall the version of the chain rule that you can use with a trig function, specifically with the secant. The derivative of the secant of u, where u can be any quantity, in this case x squared plus 3, is equal to the secant of u times the tangent of u times, and this is the most important part, the derivative of u. Again, in our problem, u is going to equal the x squared plus 3. Let's begin. So the derivative of f of x is going to begin with a factor of 3. If there's a constant in front of the secant, that's just going to be carried along. When we differentiate, it's called the constant multiple rule. The 3 will not change. Now, we will multiply by the secant of u and the tangent of u. So the secant of x squared plus 3 times the tangent of x squared plus 3. But that's not all. We have to include a factor of u prime, which in this case, the derivative of x squared plus 3 is 2x. So this is the derivative, 3 times the secant of x squared plus 3 times the tangent of x squared plus 3 times 2x. However, it's common to write any factors that are not trig functions in the front of the problem. So what I'll do is I'll take this factor of 2x and multiply it by the factor of 3 at the beginning to get my final answer in simplest form. The derivative of f of x is 6x times the secant of x squared plus 3 times the tangent of x squared plus 3.